So first I will tell, like in rectifier, whatever the rectifier will be there, if so output current will be constant. Constant current means what? That output will a highly inductive load will be connected at the output. So highly inductive means ripple free. Ripple means the constant will current will be constant. Okay, let's say output. This is the output current. Okay, ripple means what? It will oscillate between some points. So no ripple will be there or highly inductive load will be there. Then we can say that output current is constant. Okay, so if output current will be constant, in that case the shape of input current will be like this. That will be a square wave. So here I have drawn a simple square wave. This is for like diode bridge rectifier, full bridge rectifier. So source current will be like this. Okay. So if the voltage is sinusoidal, we know Vs will be, source voltage will be Vm sin omega t. And current drawn from the rectifier source, that waveform will be like this. So this waveform will be a collection of, like if we'll do the Fourier analysis of this green color waveform, so this will give like 50 hertz component. Okay, again harmonic components it will give. Okay, so which component will contribute the power? Only 50 hertz component will contribute the power. That will call it fundamental. Why? You can verify this. What is the formula of the average power? The average power basic formula is P average is equal to 1 upon T 0 to T Vt It dt. Okay, so if this V and I will have different frequency, then this average power will be 0. Okay, you can calculate. Let's say we can select a first harmonic, a sine wave. Okay, and a third harmonic. So third harmonic will be like this. Okay, so if we multiply these two, so some waveform will come and area under that waveform will be 0. So we can say that if we are multiplying two different frequency component, like say voltage 50 hertz and current, let's say 150 hertz, any other frequency. So if we'll do 1 by T integral Vi dt, so this will give 0. It means what is the conclusion? Two different frequency components, if we are multiplying, that average power will be 0. So that's why in this case, only fundamental current will contribute the power. So this a square wave we can convert into Fourier analysis. So Fourier analysis have 50 hertz component, other component also. But what will be the average power equation? Average power equation will be Vs into Is1 into cos alpha. Here alpha is the phase angle difference between source voltage and the fundamental source current, 50 hertz source current. Is it clear up to now? Why we are considering fundamental only?
Yes, sir.
Okay.
It
So
is only contribute the power, sir.
because only 50 hertz other component will not contribute the power. That's why we are considering this one, because with this equation we have observed that the average power is 0 for different frequency component. Okay. So how input power is defined for rectifier? Like power factor is like normally cos phi. If we'll do power triangle PQS. Okay. So cos phi normal like normal RLC circuit, cos phi is equal to P by S. S is what? Apparent power V into I. Okay. So here how the input power factor is derived? Apparent power we are selecting as V RMS into IS RMS. Okay. And output real power will be Vs Is1 cos alpha. So input power factor formula will be Is1 upon Is into cos alpha. So this formula we have to memorize. This is applicable for all the converter. What is the input power factor? So fundamental current RMS value divided by total current RMS value into cos alpha. So cos alpha is the angle between Vs and Is1. Okay. One another term is there, total harmonic distortion. Okay. So total harmonic distortion will be the RMS value of harmonic components, okay, divided by RMS of the fundamental. So this ratio is called as total harmonic distortion. Okay, RMS of total harmonic like second, third, and fourth, and divided by RMS of fundamental. So RMS of total harmonic, how we can calculate? It will be under root IS2 square plus I3 square plus I4 square. It will go up to infinity divided by IS1. This is the fundamental. So this we can write as IS total square minus IS1 square. So this will give this 2, 3, 4. Okay. Further we can simplify this one. So this IS1 it will go on inside the root. So we can write like this: 1 divided by IS1 by IS whole square minus 1. Further it will be 1 by DF square minus 1. So what is DF? DF means distortion factor. Distortion factor means it is equal to IS1 by IS. So this we have to remember. What is distortion factor? It is IS1 by IS. This cos alpha is called at current displacement factor, CDF. Okay, CDF, displacement factor. And this is IS1 by IS is distortion factor. So input power factor is equal to distortion factor into displacement factor. Is it clear up to now? This TSD, I think this definition you can also search. RMS of all harmonics divided by RMS of the fundamental. So this will give this short formula we have to remember. 1 divided by DF square minus 1. This will give the TSD. So DF we can calculate IS1 by IS. IS1 is the RMS of the fundamental. IS is the total RMS component. Is it clear up to now?
IS1 is the fundamental of source
IS,
voltage. Source
no,
current.
IS1, see, this is this green color waveform. It is showing source current. Okay, this green color is showing source current, and this red color is showing fundamental of the source current. Fundamental means after the harmonic analysis, the 50 hertz component. Okay, we will see next. Like I will do the Fourier analysis of this waveform. So this we will get some frequency component. So let's say this is pi, this is 2 pi. So fundamental 50 hertz component will be this. Okay, so RMS of the 50 hertz component will be the IS1 RMS. IS1 is the RMS of the 50 hertz component. Okay, and IS is the total RMS. Total RMS means this green color square waveform is there, na? RMS of this green color square waveform. So green color is the total waveform. IS1 is the fundamental waveform. Is it clear?
Yes, sir.
Clear, sir. Clear.
Okay, okay. So I'm moving to the next page. So this is one of the question like GATE 2011. Okay, so here a input current is given to a converter. Okay, input 50 hertz voltage and current drawn by the converter, it has some harmonics. So this is 50 hertz component. Okay, and this is 2 pi f. So how much? 150 hertz, and this is how much? 2 pi into how much? 250.
250, sir.
250 hertz. Okay, so what will be the average? First we'll do this one. What will be the active power drawn by the converter? So this will not contribute any power. This will not contribute any power. So this and this, what will be the power? So it will be this RMS into IRMS into cosine of the angle. Okay, so 100 root 2 divided by root 2 RMS into this one, 10 root 2 divided by root 2 into how much? 60 degree. So cos
500 watt.
60.
500 watt.
So it will be 1000 divided by 2 is 500 watt. Okay, it clear? And power factor, how we can calculate? So already I told IS1
Yeah. IS1
divided
by IS
into
half
cos
alpha.
alpha. So
Alpha is
IS1 how much? 10.
10.
10 root 2 divided by root 2. So IS1 RMS will be 10. Divided by, first we have to call IS. So IS is the summation of all these three. Okay. So this one 10 square, 10 root 2 by divided by root 2 plus
11.35.
5 square. You are getting how much? 11.35.
Yes,
This
11.35.
this only you have done 10 square plus 5 square plus
Yes,
2 square.
yes, sir. Yes, sir. Yes, sir.
So 11 point how much?
11.35.
35 into
Cos
cos
60.
60.
60.
So how much we are getting?
1 minute, sir. 50 into 10, 11.35. Sir, 0.440.
Okay, so this will be the answer. For this one,
0.44, sir.
this only. So this B option is there 0.44, and here B is there 500 watt. Is it clear? I think See, this kind of question they are repeating continuously. So, what is my plan? Like, I will cover the input power factor formula. At last, I will summarize. At last class of the rectifier, what I will summarize, how to remember input power factor formula for all kind of three phase, single phase, all different configuration will be there, semi converters and all. So I will summarize a table for all of this. Okay. So how to memorize and all the things. So that then it will be more clear. And waveform drawing also, my plan is like I will make you expert in drawing all kind of waveform. Either it will be a three phase waveform or single phase or with freewheeling diode, without freewheeling diode. So I will cover one by all those things. Like most of the people, they are getting fear in three phase, like six pulse converters will be there. There people are facing like difficulty in drawing the waveforms like switch current or diode current or something. So that thing I will cover in depth. Okay. So I'm moving to the next question. Like next concept will be there. So this is diode, simple diode bridge rectifier I have taken. Okay. So how we can draw the waveform? This is the source voltage. Vs is the Vm sin omega t. This is source voltage. Okay. So like when this Vs will be positive, then D1 and D2 will be in forward bias. This will conduct, and this is the output voltage waveform. Okay. I'm assuming that the output current is constant, ripple free. So this is the output current waveform. Further, we can draw the ID1 and ID2. So ID1 will be here, D1, D2 is conducting. So ID1 will be from here to here. And ID4 will be, this is ID4. So ID4 will be here to here. So we got this current and this current. So what will be the source current? Here if you will apply KVL, IS will be ID1 minus ID4. So this is the source current waveform. Is the waveforms are clear to all? Otherwise, you can ask. It's clear
Clear,
to
sir.
all? Okay.
Clear.
So with this one, we can calculate output voltage. So output voltage is period is pi 1 by pi 0 to pi Vm sin omega t. So already this is known 2 Vm upon pi. This is the average output voltage. Okay. And source current. So source current is a square waveform. So source current will be, the equation will be 4 I naught upon n pi sin n omega t. And this will be only for the n is equal to 1, 3 and 5. Okay. So I'm going to do how we can do the Fourier analysis. So first we will check. See formula. This is the formula. If a waveform will have half wave symmetry and odd symmetry, then like normally formula is Bn is equal to 0 to 2 1 by 2 by t. This is the formula. Okay. But if the waveform have half wave symmetry and odd symmetry, then we can use this formula. Okay, what is the formula for this one? So 4 upon t, 0 to t by 2, ft sin n omega t dt. So since this is a odd signal, an will be 0 and half wave symmetry is there, then only odd components will be there, 1, 3, 5. This is a signal concept. If half wave symmetry will be there, half wave symmetry means if I am doing xt minus t by 2, so that will be equal to minus of xt. So this is called half wave symmetry, and xt is minus c is equal to minus xt. This is odd signal. So in that case, we can apply this formula.
Sir, 1 minute.
Yes,
How to identify signal is a hard signal or
see,
even
odd signal is equal to x minus t is equal to minus xt. Okay. So here x minus t if will do, this will like mirror image will come. Okay. This will come this side and this will come this side. Mirror x signal we have
mirror image.
mirror image with respect to x-axis. X minus t means mirror image with respect to x-axis. So this will go this side and this will go this side. Okay. If we are multiplying by minus, so that also will do the same thing. This minus will become positive and here plus will become minus. So x minus t means mirror image, or minus of xt means this every component will be multiplied by minus 1. So here if we are multiplying by minus 1 this side, it will come here like this. And here if you are multiplying by minus 1, that will come here. So we can say that x of minus t is equal to minus of xt for this signal. Is it clear?
Yes, sir.
Okay.
Yes, sir.
This we should remember. X of minus t is equal to mirror image. That you can
Like, sir, sinusoidal waveform with odd signal, sir.
sign. Let's say this one.
Oh, yes, sir.
So if we are doing mirror
Positive,
image, uh,
positive half cycle mirror image to negative half cycle.
okay, that is mirror image only. 1 second. 1 second. Hmm. Is it clear?
Yes, sir.
X of minus t will do not mirror image. See, x of minus t means this will go this side and this will go this side. So this negative will come here. Similarly, x of minus t means we can say mirror image only. This will come this side and this will come this side. Okay. So this
Oh,
and we are multiplying by minus one. Then also here also same. See here also if we are taking mirror image, this point will come here and this plus will come here. If we are multiplying by minus one also, so then it will be same. So sine, what we can say, sine is already odd, na? Sine omega t.
yes, sir. Yes, sir.
So this is the concept. Okay. So when in any signal, if we'll observe this kind of thing, then we can say that this is odd signal. And half wave means what? X t minus t by 2. So t by 2 is pi. If we are doing this one, so what will happen? Signal will be minus of that. Okay. So it will come here. T minus t by 2 means this will shift it to here. Again, that will be like plus will come here. So that will be minus of xt. This equation is clear to all? How shifting is happening? Xt minus t by 2 is equal to minus xt.
Yes, sir. Yes, sir.
Okay. So if this first we will check these two conditions. Otherwise, if this condition will not be there by some shifting or something, we will make this condition. Okay. And then we will say next step we will do the Fourier analysis. Okay. So this formula we should remember. In if this will be there 4 by t 0 to t by 2 xt sine omega n omega t dt. Okay. So here I am getting 4 upon 2 pi 0 to pi. So omega is equal to 2 pi by t. Time period is pi, so omega will be 1. So I am writing here sin nt dt. Okay. So it will be 2 I naught upon n pi minus cos nt 0 to pi. Okay. So finally we can write bn will be 2 I naught upon n pi minus cos n pi plus 1. So this value will be 0 when n will be 2, 4, 6. Okay. And it will be 2 for n is equal to 1, 3, 5. So we can say that bn is equal to 4 I naught upon n pi for n is equal to 1, 3, 5. And Fourier nth term we can write n cos n omega t plus bn sin n omega t. So n is 0 here. So we can say that in is equal to bn sin n omega t. Is it clear? Can anyone reply?
Clear, sir.
Okay. Okay.
And sir, A0.
A0 will be 0. See, A0 will be 0 since positive area and negative area are same here. Okay. So average A0 means average. Average under this curve will be 0. So A0 will be 0. Is it clear? See, if this negative portion will be less and positive portion will be more, then only this average means what? A naught means what? DC value. So DC of this waveform 0 to pi, pi to 2 pi. So 0 to pi it is I naught and pi to 2 pi it is minus I naught. So this plus area and minus area is equal. So A naught will be 0. Is it clear? Can I move to the next?
Clear, sir.
Okay, okay. So final equation will be nth harmonic equation will be Is of n will be equal to Bn sin omega t. So 4 I naught upon n pi sin n omega t. N is equal to 1, 3, 5. Okay. So how we can calculate the fundamental current? So for n is equal to 1, it will be so n is equal to 1. So 4 I fundamental peak value will be 4 I naught upon pi, and RMS will be divided by root 2. So it will be 2 root 2 upon pi into I naught. So this will be the RMS value. Okay. And source RMS value how much? Source RMS value will be
Sir,
equal to
how
I.
did you calculate this IS1?
See, IS nth harmonic component is IS n is equal to Bn sin omega t. See, any harmonic we can write an cos n omega t plus Bn sin n omega t. Okay. So here we have calculated Bn value 2 I naught upon n pi. So Bn will be 4 I naught upon n pi for n is equal to 135. For 246 it will be 0. See, cos 2 pi will be 1 and 1 minus 1 will be 0. So for or even harmonics, this Bn factor will be 0. Odd harmonics it will be 2. So final Bn value is 4 I naught upon n pi. So we can write this one Bn sin n omega t. So ISN nth harmonic current, this is the Fourier. 4 I naught upon n pi sin n omega t. So this is nth harmonic component. Here for fundamental means first harmonic value of n will be 1. So IS1 will be, this n will be 1. So 4 I naught upon pi from this equation. Okay. And RMS it will be divided by root 2. So that will be 2 root 2 upon pi into I naught. Is it clear?
Clear, sir.
Clear,
Clear.
sir.
And the source current, this is the fundamental RMS. What will be the source current RMS value? That will be I naught only. Is it clear why it is I naught? Source current RMS. This is the RMS of the fundamental. 2 root 2 by pi I naught is the RMS of the fundamental. Okay. Here the output current is constant I naught. Okay. And source current is a square wave. So the source current RMS value will be that a square wave RMS. This is a square wave. This is a square wave is there. Peak is I naught and minus I naught. So this RMS value of this wave will be I naught. And the fundamental is this one. So this value is 2 root 2 by pi into I naught. So is it clear why the source RMS is I naught? Should I explain this? We can calculate this. See, this waveform is present for full cycle. Okay. Is it clear? Is it clear to all? Why this?
For square wave, RMS value equal to peak. I know, sir.
Constant. You can calculate
Constant.
that. Like
Yes. For
if any
square wave, RMS
if,
value is nothing but amplitude, sir.
yes,
Average
yes.
value equal to RMS value equal to amplitude of the waveform for
Yeah.
square wave.
Yes. We can calculate this by basic formula. Basic formula we already know how to calculate the RMS value that we will apply. We will get the constant value only. Okay. So IS RMS is equal to I naught. So what will be the distortion factor? DF. DF will be IS1 by IS. So 2 root 2 upon pi. And here this alpha is 0. See, fundamental, this is uncontrolled. This will start from here only. So the voltage waveform is also here only, and fundamental will also start from, let's say this is voltage waveform. Okay, and this is fundamental waveform. So angle between both two will be 0.
Zero, sir.
So input power factor will be same as this one. Cos 0 we can multiply.
0.9.
So 2 root 2 upon pi.
0.9, sir. 0.9.
It will be 0.9.
0.9.
Okay. So how we can derive this without knowing the Fourier equation? Okay. For any kind of converter, we can use this rule. Okay. How we can derive this in source current? IS1, how we can derive without using this, if we don't know this, let's say we forgot this equation. So how to derive the IS1? So we can apply power balance. Input power should be equal to output power. Okay. So we can write Vs into IS1 into cos 0. This should be equal to output DC voltage into DC output current. So output DC voltage for this one 2 Vm upon pi into I naught. And this RMS value we can write as Vm divided by root 2, the source voltage. So Vm by root 2 into IS1 into cos 0. This should be equal to 2 Vm upon pi into I naught. Okay. So from here we can see that the Vm will cancel. IS1 will be 2 root 2 upon pi into I naught. Is it clear?
Sir, why cos 0?
See, Vs IS1, we cannot, already I told no, input power, how we can input voltage, source voltage will be there, and fundamental source current will be there. Okay. So what is the power? Real power, how we can define? Vs into Is into cos of angle between voltage and current. So this voltage is here and current is in the same phase of the voltage. Since this is uncontrolled, so alpha will be 0. Okay. So that's why This current and voltage, this is the voltage, source voltage, and this black color is fundamental current. So angle between the source voltage and fundamental current will be 0. That's why input power we can calculate Vrms into IS1 RMS into cos 0. Is it clear?
Sir, yes, sir.
Clear, sir.
Okay. So this we can use for all converters. Like in this way, if you forgot the formula, like what will be the IS1 formula, if you forgot, you can apply this power balance equation. So Vs into IS1 into cos 0 should be output power. Input real power should be equal to output real power. And output real power in case of this constant value will be V average into I average. Okay. So from here, we are getting the same thing, 2 root 2 by pi into I naught. Same thing we have derived here also. We can get the same thing by power balance. Is it clear?
Sir, in case of thyristor, we have to
Uh,
consider alpha.
That also I will discuss next part. Already it is there. Next I will discuss.
Okay.
Today only I
Yes,
will
sir.
discuss that one also. Okay. So some questions we will do first. After that I will move to the fully controlled rectifier. So this is very easy. Get 20 question. I think you can, all of you can answer. A single phase full bridge diode rectifier fed from 230-50 Hz sinusoidal source supplies a series combination of infinite resistance and very large inductance. So very large inductance means what? This is a ripple free current, ripple free output current. So if this thing will be written large inductance or ripple free, it means that output current is constant. Okay.
Constant.
So what will be the dominating frequency component? Can anyone reply? Already we have done the Fourier analysis.
See, D, sir.
No, think again. What will be the, see, this is the source current will be there. Okay. This, since supply voltage is 50 Hertz, so source current frequency also will be, this is the source current, pi 2 pi. So what will be the fundamental frequency?
50 Hz.
50 Hertz. So Watt's harmonic will be there. First harmonic, let's say third and fifth. Third and fifth will be there. Okay. So dominating component in this signal will be 50 Hertz. That will be fundamental. After that, the second dominating component will be third harmonic. So 150 Hertz. So in this current signal, dominating, like it's not asking harmonic, dominating frequency component. So it will be the highest dominating component,
Option
that will
C,
be
sir. 50, 150.
50 Hertz and 150 Hertz. If you'll ask like what is the dominant harmonic components, okay, then we can say that 3 and 5. Here people will do mistake. Dominance harmonic, dominance frequency component it is asked. So 50 Hertz also dominating frequency, highest dominating, magnitude will be higher. After that 150 Hertz magnitude will be there. Okay, so these two are dominating frequency. Option will be C. Is it clear to all? Okay. So this one question I have taken, one question. So here I am not mentioning, in first case I am taking resistive load. Okay. So in case of resistive load, what will be the output current? Whether it will be continuous,
Continuous, sir. Continuous.
but whether it will be ripple free or with ripple, like
Sir, with ripple.
Ripple, sir.
yes, we can draw here. Like let's say this is output voltage. Okay. So V by R
Sir,
current
same as output
current
voltage.
waveform will be less than this. Will be this one.
Pulsating. Pulsating.
Like this only. So what will be the average power in this case? How we can calculate? What will be the average power?
Sir, VO into IO.
Sir, 800 watts, sir.
800. How we have calculated?
Average power means average output voltage square by 50.
No. That is not correct. See here only. I will explain one basic equation. Okay.
Oh.
Where we are taking average. So,
Across 50 ohm resistor, sir.
so this is output voltage.
Output voltage.
See, one basic equation already I have discussed in my earlier classes. Now I am also repeating. Average power formula, P average. This should be equal to 1 by T, 0 to T, Vi dt. This is average power formula. Okay, we know V of t. This is V of t. This is I of t. Okay, so if we'll do this one, so this is what Vm sin omega t, and this is Im sin omega t. Okay, so if we'll multiply the instantaneous voltage into instantaneous current, we will get power curve. Okay, so power curve will be somewhat like this. Okay, it will be like this. So here Vm Im sin square omega t. This will be the value, instantaneous power. So this is pi and 2 pi. If we'll integrate this value from 1 by t 0 to pi, then we will get the average value, average power. Okay. So where we will take average, let's say this current is constant. Okay. In second case, what I am taking, current is constant. So current is constant means this constant value we can take outside. So I am taking outside. So 1 by t 0 to t v dt. Okay. So when here we can say that what is the average output power? Average output power is equal to this 10 ampere current. Okay. This 10 ampere current into this what we will call 1 by t 0 to t v dt, average of the voltage, V average. This is the average formula. So when we can take average value. So average value we can take when either one of these will be constant, that we will take outside. So another will be average. Okay. But here we are seeing that both things are variable. Neither voltage is constant, neither current is constant. Both are variable. In that case, what we will take? VO RMS whole square by R. So what we should remember, if both voltage and current are variable, okay, V is variable and I is variable. So in that case, we have to calculate the RMS. Okay, if either one is constant, let's say here in this case I is constant, so I am taking outside. Okay, so remaining term will be 1 by t 0 to t v dt. So this will be the average value of the voltage. So here in this case, we can calculate the average value and then we can multiply with 10, so that will be the average power. Is it clear? Is it clear to all?
Clear, sir.
This will verify. See, this power will verify. So we can, what will the VR?
400 watts, sir.
That will be 400 watt.
Sir, VRMS is nothing but 200 by root 2, sir.
200 by root
Here,
2.
here maximum value is 200, sir.
So this will be
Input
200 root 2 square by 50. So this will be 400 watt. Okay. With this,
V naught
with
V
this,
naught RMS 141.421 volts.
okay. So 400 watt is the correct answer. This is also previous year gate question. Okay. So this is the only fundamental question where we have to be careful. Why RMS? That I am going to prove with this waveform. So what is the average? Basic we should know. This is the basic formula. So here how we can do 1 by t, 1 by pi, 0 to pi, Vm Im. So Vm is 200. What will be the Im value? 50 by 200. How much? 4. 200 into 4. Is it okay? This is 200 Vm. Im will be, so 4 into sine square theta d theta. Is it okay? This average power waveform. It should come 400. Okay.
Okay.
Is it clear? So I am going to calculate this 1 by pi 0 to pi. So this is 200 into 4. How much? 800. 1 second. 800 by pi sine square omega t. So we can say that 1 minus cos 2 omega t by 1 minus cos 2 theta by 2 d theta. Is it clear?
Yes. Clear, sir. Clear.
So it will be 800 upon pi. So we can say that 400 upon pi.
Yes, sir.
Here first term will be theta. So pi minus 0. Okay. And what will be the second term? 1 by 2 sine 2 theta. So
Second
0,
term 0.
so it will be 0. So what we can say? It will be 400 by pi into pi. So it will be 400 watt. So this is verified. Like we have to take like RMS value in case of the, if resistive load will be there and current will not be constant. In case of resistive load, we should take the RMS value. So one of the fundamental concept will be we should check voltage and current. What is the voltage and what is the current? If both will be variable, we will take RMS value. If either of one will be variable, let's say voltage is variable and current is constant. So in that case, I will come outside 1 by T V dt. So this will be I into V average. Okay. So for second case, can anyone calculate the power? What will be the power value here for second case? What will be the power here? So here current is constant. So what we will take? Average of voltage. Okay.
1000, sir.
Now what is
1000
it?
watt.
2 Vm upon pi. Average of voltage will be 2 Vm upon pi into current how much? 10. Can anyone calculate? I'm also calculating. So 2 into Vm how much? 200.
Sir,
Divided by
1274, sir. 1274.
yeah, it will be approx
74.
1274 watt. Okay. So next time, like this is a normal. Another type of question also can be formed. Like let's say in device losses. Okay, device losses we are calculating. Let's say IGBT switch is there. Okay.
Sir, I have one doubt, sir.
You can ask.
Previous diagram.
Okay. Okay.
Sir, here resistor load, we took RMS value, sir. Here, why, sir, average value? We took
Second
second
case.
diagram.
Again, I'm explaining same thing. 1 second. The basic formula we should remember. Okay, what is the basic formula? P average for any two waveforms are there. One is voltage waveform, one is current waveform.
Yes,
So P average will be
1 by 1 cycle
1 by
distance
T,
or 1 cycle.
0 to T. Instantaneous power is V into I
V
dt.
of T into
So
I
we
of
will
T.
multiply V into I, and what will be the period of V into I, that we will take. Okay. So B some waveform will be there, I some waveform will be there. This both waveform will multiply. That third waveform will come. This T is the period of that third waveform. Okay.
Oh.
So
Okay.
so here if we'll
Both are
see.
varying.
So here across the resistance, the current is also varying, voltage is also varying. Okay.
Okay.
But here, second case, current is 10 ampere. So what I will do, 10 constant we can take outside. So 10 I am taking outside. So 10 into 1 by T integral V dt. So what is this value? 1 by T into function into dt will be average value.
Average voltage waveform average value.
So voltage average we are taking, and current already constant. So by one constant will be there, so another average we will take. Okay. In another case, we can say that if if voltage will be constant, any other case will be there. Let's say some
We will take average value of current.
one example I am giving. Let's say one device is there, IGBT switch is there. Okay. Here device drop is there. Let's say 0.2 volt or 0.6 volt. Let's say, and some current waveform is flowing through this. I is flowing through this. So I want this device loss. Okay. So device loss means voltage across device. So P will be 1 by T VI dt. So here voltage is constant. Let's say this is some current. Let's say some like this kind of current is flowing through this. Okay. So what we will take? I will take the voltage outside. So 0.6 I will take outside, and will be
Average value of the current.
So average of the current. So what is this we should remember? Basic formula. Any scenario will be there where one of this will be constant. We will take the average of the another signal. So in case of resistance, what will happen? Let's say resistance is also there in this. Some internal resistance is there. Okay. Current is flowing through this. So here what will be the voltage? Voltage also will be variable here across the resistance. It will, let's say this it will vary according to this current. So V is equal to I into R. This will not be a constant. So in case of when the resistance across the device will given, and that case what will the loss? I RMS square into R. And device drop, what will be the loss? VD into I average. Is it clear? Is it clear to all?
Clear, sir. Clear, sir.
Okay.
Thank you, sir.
Okay. So overall for device, I will one questions already are there. How they will give for device question? Let's say some resistance will be there, and some device drop will be there, and I will flow. Some I waveform will flow. Let's say a square wave or something. Okay. So they will ask total average power. So total average power through device loss will be I RMS square into R device plus I average into V device. This will be the total average power. So for resistance, we are taking RMS, and for device drop, we are taking the average. Why we are taking that already I have explained. Is it clear?
Clear, sir. Clear, sir.
Okay. So this value will be 1247 watt. Now moving to the next question. See, any basic doubts you can ask. I will give time to explanation. Okay. Don't worry. All things I will repeat again. The main thing is concept should be clear. This is GET 2021 question, diode rectifier based only. So it is asking what will be the peak inverse voltage, okay, seen across any diode. So peak inverse voltage means reverse voltage through the diode. So this is Vm sin omega t, okay, and when this D1 and D2 will conduct, so D1 and D2 will conduct, and this plus will go here. So this is sorted from here to here, okay, and this is sorted. So this will conduct like this. So what is the voltage here? Plus and minus. Let's say this is Vs plus minus Vm sin omega t. So this Vd will be Vm sin omega t. Same value will be there. Let's say this is okay. So during first case, D1 and D2 will conduct, and during second case, D3, D4 will conduct. So when D1, D2 are conducting, what is the voltage across D3? Uh,
VM.
Vm.
D3 is open, sir. D3 is open.
D3 will be open. So that's
Open means voltage across D3 is nothing
this
but
plus and here
VM.
minus.
Input
So
voltage.
VD3 will be minus of this one. This here plus, I'm taking here minus. So if you write KVL in this one, so VD D is equal to minus of VS. Is it clear? Again I will explain.
Sir. Yes, sir.
Let's say here plus and here minus. A device voltage will be plus and minus. So VD will be VD3 will be minus of VS. So that will be like this. So what will be the peak inverse voltage? Every diode will be a phase like this only. So peak will be this value, that is peak value. So how much it is given? RMS value is given 230 plus minus 20%. So peak will be Vm minus Vm. This will be, so 230 into 1.2 into root 2. How much?
390.32 volts.
390.3. So this is already asked 2020. See, this kind of easy questions are asked. Okay. Power electronics, if your concepts are clear, you can score at least 8 to 10, 8 marks easily you can score. It's very scoring subject. At questions from here, they will ask easy questions only. So they move to the next question. Next concept.
Yes, sir.
See, so fast, I will cover this fast. So this is a diode controlled rectifier. Okay. Maybe all of you know this waveform. So this is source voltage. Okay. Output current here I'm assuming ripple free, constant current. So we are triggering at alpha we are triggering, okay, current, so it will go pi again, it will go here, since the current will be there, so the voltage will be come like this, here. So this is the output voltage waveform. Here here to here T1 T2 will conduct, here to here T3 T4 will conduct. Okay, is it clear why it is going negative? Anyone have doubt they can ask, I will explain.
Due to inductance, sir.
See, current is constant means current will be constant only. The current is flowing. Okay, so where this current will flow that through that path only. Okay,
Can you explain, sir, why?
let's say T1 T2. Okay, we are firing at alpha T1 and T2. So T1 T2 will start conduct at pi. If resistive load be there, current should be 0. But since this is high current and we are not firing T3 T4, T3 T4 are not fired till pi plus alpha. At pi plus alpha we are firing T3 T4. So this current will be flowing in T1 T2 only. So if T1 T2 will be there, so this is Vs. Okay, so this negative part will come there. Here this is plus and this is minus. When T3 T4 will conduct, then it will invert. But when T1 T2 will conduct, then same waveform will come at outside. So from here to here T1 T2 are conducting. So this waveform will appear here, from here to here. After pi plus alpha only we are firing T3 T4. So this current have only one path T1 T2 that are already in conducting mode. Okay. So since conducting mode, highly inductive current will be there, that current needs some path, but that will not flow through T3 T4 because we have not fired those switches. Okay. Since they are in forward conduction mode, but still firing pulse is not given. So without firing pulse, this T3 T4 will not conduct. Okay. So when we are giving firing pulse to T3 T4, then this current will be carrying by this T3 T4. Okay. Here this T1 T2 will be in reverse mode. T1 T2 will be in the reverse conduction, reverse bias mode. Okay. During negative half cycle. Is it clear? Otherwise, I will explain again.
Uh, then,
You can ask.
sir,
Yes.
when we trigger T3 and T4
Yes.
uh, at a pi, then what happens?
If we'll trigger, see, for full bridge rectifier, the cycle will be alpha pi plus alpha. This is the cycle. Like here, if we are triggering at alpha, so for bridge we should trigger here one. If we'll trigger here like in one half cycle we are triggering at another angle, then different kind of thing will happen. Okay. If we are triggering here only, then from here only it will start picking up. Okay. Right. We can draw that waveform also. Let's say positive half cycle alpha I am triggering. This is a new kind of analysis. I think till now in GATE they have not asked. So let's say this is pi. First I am triggering alpha. Again pi only if I am triggering, then it will come here like this one, 2 pi. Okay. Again in section I am doing like this one. So the waveform will be like this. Again and again like this. Is it clear? Is it clear, or otherwise I will draw on the next page?
Yes, sir. Sir, this is for one asymmetrical circuit, sir.
Not asymmetrical. Like you asked that what will happen in first half we are firing at alpha. In second half here we are firing at pi only, not at alpha, at pi only. So
Okay, okay.
so what will happen? Let's say first alpha we are firing, so it will go pi. Again at pi only if we have fired the T3 T4, then here only it will pick up pi to 2 pi. Okay, and this current will be like this. So again here it will be like this one, and again for next cycle it will be like this one. So one cycle will be like this one. I see question can like this can be framed. Like they can ask T1 T2 at alpha. Like this sequence will be repeated. In next cycle they are firing at T3 T4 at 0. T3 T4 at pi. Phi we can say that this is pi and this is 2 pi 3 pi. So we can say pi 3 pi, and this is T1, T2 alpha. Let's say this is alpha, this is 2 pi plus alpha. Like this sequence can be given. So waveform will be like this. This is alpha, this is pi, this is 2 pi. Okay. So what will be the average output voltage waveform? We have to integrate from here to here. That will be one cycle. Okay. Is it clear? That you can explore like this kind of things. Is it clear to all?
Clear, sir.
Okay. Okay.
Sir, after 1 minute, sir.
You can ask.
Sir, in after pi T1, T1, T2 are
See what
reverse
will
bias.
happen.
For that reason, negative spike occur.
Hmm.
Sir,
You can ask.
previous diagram, sir. Previous diagram.
Okay.
Here in second waveform, sir, after pi T1,
See T1, T2 is
T1, T2 are reverse biased.
T1, T2 is reverse bias, but it is conducting. Why it is conducting? Because highly inductive current is there, and since
Yes,
we have not fired this T1, T4, so that current will flow through T1, T2 only. So since it's flowing through T1, T2 only, VO will be VS. So VO will
yes,
be VS means this same waveform will be kept here. Here
yes, sir.
at pi plus alpha T3, T4 will be fired. So this will take up the current. So output will be reversed. Okay.
Okay, sir. Okay, got it, sir. Got it.
Okay. So this is the
Thank you, sir.
source. Okay. So this is the source current waveform here. Okay. It will start. It is a shifted current waveform. Previously it was starting at 0. Here it is starting at alpha. So alpha pi plus alpha 2 pi plus alpha. So this is the source current waveform, and output average voltage will be here alpha to pi plus alpha Vm sin omega t d omega t. So it will be 2 Vm upon pi cos alpha. This will be the average output voltage. Okay. Is it clear?
Clear, sir. Clear.
So
Sir,
yes, you can ask.
from pi to pi plus alpha, sir, I couldn't understand.
Here pi to pi plus alpha, this one.
Yes, sir.
Okay, I will explain again. See, alpha to pi T1, T2 is conducting. Okay, at pi 0 crossing is there, but since our output current is constant, this is output current, highly inductive current. So that current needs some path where, see, T3 and T4 we are firing at pi plus alpha. So before pi plus alpha, this T3, T4 will not conduct. So since this will not conduct before pi plus alpha, this current needs some path. So already conducting switches will conduct this current. Okay. This current will not become zero. Okay. Because since output highly inductive current is there, this current will flow through this already conducting switches is there. So this inducting current is, since inductor like it will not, a sudden change in current should not happen. Okay. So this current will flow through this T1, T2. Since this T1, T2 is conducting, when T1, T2 will conduct, what will be the value of output voltage? VO will be VS. And when T3, T4 will conduct, VO will be minus VS. So here to here, this is the output voltage waveform. So T1, T2 is conducting. So T1, T2 will conduct, same waveform will come here. So here to here, same waveform, here to here. That is the output voltage. When T3,
Sir,
T4,
pi to pi plus alpha voltage is negative, but
see, same waveform, no? See,
Input voltage also negative, sir.
that same is coming at output. When T1, T2 will conduct, this T1, T2 will, here we can write KVL. This is plus, this is minus. This is plus, this is minus. Okay, this is source voltage. So T1, T2 will conduct, output voltage will be equal to the source voltage. And when T3, T4 will conduct, output voltage equal to minus of source voltage. So here to here, T1, T2 is conducting. So T1, T2 conducting means it should be same as source voltage. So source voltage is also negative here. That's why it is coming negative here. Is it clear?
Same source voltage appear across the load.
Yes. This waveform is clipped and it is coming here. Again, pi plus alpha to 2 pi here, 2 pi plus alpha. Okay. Here T3, T4 is conducting. So we are getting inverse of this. So inverse of
Inverse
this.
of source.
So
Okay. Yes.
so it is coming like this one. Is it clear now? I think.
Yes, sir. Yes, sir. Clear, sir.
Okay. Okay. So this thing you can analyze like this kind of waveform, like if second we are doing at pi also, so what will be the average power that you can calculate? Okay. See, you can also do experiment like new thing, like if you'll remove this diode, then what will be the waveform? That kind of experiment you can, it will improve your thought process. Okay. So for Fourier analysis, what I told, like this is the waveform. So waveform is neither even nor off. Okay, symmetry is not there. So what we will do, we will first make it symmetry. Okay. So what I am doing, I am shifting this value waveform here by alpha. So this is the shifted waveform, F2. So F2 is what? This is similar to our first waveform. Okay. This is odd and half wave symmetry is there. So what will be the Fourier for this one? 4 I naught by n pi sin omega t, n is equal to 135. Okay. So after shifting we have calculated. So what will be the Fourier of this one? So f1t we can say that f1t is equal to f2t minus alpha. So is of n for this will be, since this is sin n omega t, so for this one will be 4 I naught upon n pi sin n omega t minus n alpha. Okay. Is of n will be 4 I naught upon n pi sin n omega t minus n alpha. Is it clear? See, you can do for this directly without shifting. You can also do. You can calculate an, bn. Okay. After that, you can simplify that equation. Then you will get this final value. So, what is the best method? First, if non-symmetrical waveform will be there, first we will make that symmetrical. Okay. So, after the symmetrical or non-symmetric waveform, just that will be shifted. So, ISN will be 4 I naught upon n pi sin n omega t minus n alpha. Is it clear to all? Can anyone reply?
Clear, sir.
So any converter like either 3-phase or 6-pulse, any converter, source current waveform, it will not be symmetrical. First we will make symmetrical by shifting, and how much angle is shifted, that will come here, sin n omega t minus n alpha. So this will be the nth harmonic. So IS1 will be 4 I naught upon pi sin omega t minus alpha. Okay. So this black color waveform is the fundamental waveform shifted by alpha. Okay, this voltage will start from here. Source voltage will be somewhat like this. It will be here. 1 second. This is pi plus alpha. 1 second. It will go here only. So source voltage. This is alpha. This is pi, I think. So source voltage will be somewhat like this. Okay. And this voltage, fundamental voltage is alpha difference is there. Alpha lag is there. Okay. So this will be the input power factor. Here the displacement is there. This is source voltage and fundamental source current is alpha shifted from the source. This is alpha. So input power factor will be IS1 by IS into cos alpha. This will be 2 root 2 by pi upon cos alpha. Okay. Is it clear to all? Yes, derivations.
Similar to previous one, sir, but here alpha is changing, sir.
Alpha is there. See, previous case, our square wave was like this. Okay. Then source current was also like this. And voltage, source voltage was like this. So phase difference was not there. But here, in this case, the current is shifted like this. Okay. But voltage will be same. So voltage will start from here, but current will start from here. This will be the fundamental current. So this shifting between the source voltage and fundamental source current will be there. That will called as alpha.
Alpha times were shifted.
Yes. So that's why here, what will be the input power? Vs into IS1 into cos alpha. Here input power will be Vs IS1 cos alpha divided by Vs Is. So that will be the input power factor. That will be IS1 by Is into cos alpha. So that will be 2 root 2 by pi upon into cos alpha. Is it clear?
Yes, sir. Clear, sir.
Okay. So some questions are there that I will discuss in next class. Okay, one by one I will.
One question, sir.
You can ask.
Let's solve one question, sir. No.
Okay. So easy only, like not this one. Say this one. 2008. Okay. So single phase full control bridge converter supplies a load drawing constant and ripple free load current. If the alpha is 30, what will be the input power factor? Simply we can write 2 root 2 upon pi into cos 30. How much? This will be, I think, 0.78. Already we have
0.78.
See, same question I will show you. Same question is repeated once again. I think some question. See here, 2014, I think. So same already asked in, see which year it is asked, 2008 it is asked. Okay, again in 2014. You see, alpha is 30. This is same question. 0.7. Here they have asked in the fill in the blanks type question. Again similar kind of question they have repeated in 2019, I think. This, okay, the power factor. Okay, so this is 2019. Just they have asked in a different way. Alpha they have not given. Alpha information we have to calculate, like output voltage is given, source RMS value is given. So 2 Vm
2
upon
Vm by pi. 2
pi
Vm by
cos
pi into
alpha
cos
should be
alpha.
equal to
V
V
naught.
naught.
V naught.
So from here we can calculate the cos alpha. Okay, and the input power factor will be 2 root 2 pi
0.9 into
into
cos alpha. 0.9 into
cos
cos alpha.
alpha. Clear? So see, these are only for basic full bridge converter. I will one by one. I will take the different kind of cases like semi converter, three phase semi converter. All thing at last, what I will do, I will summarize all the formulas and short tricks like how to remember them. And my plan is to cover up all the gate previous year question. Okay, and the some other questions that I will take, like some conceptual questions will be there that I will take. Okay.
Okay.
So how is the session today? Is it
Good, sir. Good, sir.
so my plan is to clear your fundamentals. Like first I have explained like what is the average power and all, like where someone have done the mistake, like average power. That should be clear. Okay. And we'll meet in the next class. So some questions I will solve, and if time will be there, maybe three phase I will start in next class, or single phase remaining all questions I will try to cover. Okay, after the completion of all get previous year single phase questions. So I will start three phase, and after three that overlapping part I will cover at last, like source inductance based questions that I will cover for single phase and three phase both at last. Okay.
Okay.
Okay. So thank you all.